Hello everyone. Now I am discussing a question of matrix in the series 2. So the matrix is A 2 2 1 1 3 1 1 2 2 has eigenvalues. So this is our question and these are the options given below. So solution is like this. A matrix Aij 3 cross 3 matrix has characteristic equation can be written as lambda cube minus lambda square trace of A plus lambda trace adjoint of A minus determinant of A equals to 0. This characteristic equation we get from solving the Cayley-Hamilton theorem or from A minus lambda I is equals to 0. So on putting the eigenvalues we have to get this characteristic equation. So what are this here? What are the different things here? That is trace of A, trace of adjoint of A and determinant of A. Trace and determinant I have told you in the previous lecture in the series 1. Trace is equals to sum of eigenvalues lambda 1 plus lambda 2 plus lambda 3 and determinant is equals to product of eigenvalues. So this is from the eigenvalues you have to find trace and determinants. How these values are found from the matrix? So trace is sum of eigenvalues which is equals to sum of diagonal elements of the matrix. So 2 plus 3 plus 2 we get 7. So this is trace. Now the determinant, how we find the determinant? Lambda 1, lambda 2 and lambda 3. So this is from the eigenvalues. Here I am telling you how to find the determinant using Sere's rule. So this is using Sere's rules. Sere's rule. What is Sere's rule? 2 into 3 into 2 means we get 12. 2 3 is 6 to the 12. Now 1, 2 and 1. Here this. In this direction you have to take. So what we get? 2. In the same way 1 is multiplied by 2 and 1. So we get 2. This is in anti-clockwise direction. Now in clockwise direction, how we have to find? We have to find the second part like this. 3 ones are 3 and this 3 and 2 ones are 2 and this multiplied by 2. So we get 4 and this 2 and this 2 we get 4. So on substituting this, from simplifying this, 16 minus 11 is equals to 5. So this one is the exact determinant value. Now you have to find the determinant. Now the third thing is trace of adjoint of A. You know that trace is sum and adjoint is what? On hiding 2, 3 2s are 6 minus 2 you get this. Then hiding 3 means hiding diagonal elements. Hiding 3 means this row and this column. So 2 2s are 4 minus 1 and hiding 2 you have to hide this. So 3 2 is 6 minus 2. So you get this value. You get on simplifying 11 here. And now this is the characteristic equation. You have to put trace here, trace of adjoint here, the second part, and last one is the determinant of this. So now the 3 on substituting we get this is the quadratic equation of third order. Now you have to solve this equation using the method studied previously. So lambda is equals to 1 satisfying this equation. Putting lambda is equals to 1 you get 1 here. Here you get 7. Here you get 11 and 5. On simplifying it is getting 0. So lambda minus 1 is the eigenvalue of one of the value of this equation. So on simplifying you get lambda is equals to 1, 1 and 5. Now this one is the detailed method. I am telling you the shortcut of this method. So first you have to learn the node point. What is node point? If lambda is the sum of entries of each row oblique each column, then lambda is an eigenvalue of a matrix A. Lambda is the sum of each entries. So here you see this row 2, 2 and 1. This first row 1, 3 and 1. The second row 1, 2 and 2. This third row. On adding these you get 5. So 5 must be an eigenvalue of this matrix. Now you have to find the other two eigenvalues. So one eigenvalue you have to get from this and the other two, for other two you are using these two equations. So for trace 2 plus 3 plus 2 means 7. So 7. So for getting 7 now you have to see from the option that 2 plus 3 plus 2 this is 7. So this may be the answer or this may be the answer because you are getting 7 from in these two options A and D. But this shortcut trick shows that 5 is one of the eigenvalue means this one is the correct answer. You are getting one of the eigenvalue 5 and 1 is the other two eigenvalues. So this is about the question. Now this is the second question I have taken from the GATE 2013 exam. The question is m is equals to 4 minus 1 minus 1 minus 1 4 minus 1 minus 1 minus 1 and 4. So there is symmetry in this matrix. The question is, the degenerate eigenvalue of matrix is, your answer should be an integer. This is your question. The solution is like this. You have to write this matrix in the form of this plus 5 or this. This is called the identity matrix. So you can break this matrix in this form. Now you know, in the first lecture I told you, when all the eigenvalues of the matrix are same, then their eigenvalues, all the elements of the matrix are same, then their eigenvalues are repeated. So this is of order 3 cross 3. So 3 minus 1 means 2 eigenvalues are degenerate or repeated. That is 0 and 0. And third one is sum of the diagonal elements, means minus 1 and minus 1. So this is minus 3. And from this you know that identity matrix has all the elements 1, 1, 1 and 1. Taking 5 as common in this, on adding this you get finally this matrix. So you get the eigenvalues from these two matrices 0, 0, minus 3. So you are adding this, so because of this you have to put plus sign here, and 5, 1, 1, 1 are the eigenvalues of this identity matrix. So on adding or simplifying this, 0 plus 5 you get 5, 0 plus 5 you get 5, minus 3 plus 5 you get plus 2. So the question is the degenerate eigenvalue. Degenerate means repeated. So 5 is the answer and it must be an integer. So this one is the correct answer. This is about the question. Thank you very much. Keep watching.